Next, we are going to talk about investigations that we do for ear problems. Right now, we are only going to discuss investigations for ear. Nose and throat we'll discuss later on. Now we know that ear is divided into has two functions. One is hearing and one is for balancing. And on the same basis, we have divided the test for ear into two parts. One of them is hearing test that checks the cochlea, basically the hearing part of the ear. And the second one that checks the balancing is called the vestibular function test. We all know balancing is done by the vestibule, so the tests are called vestibular function. So hearing test, vestibular function test, and each of them can be divided into clinical and laboratory test. Similarly, vestibule can be divided into clinical as well as lab test. Now, in the clinical test for hearing, the only important test is tuning fork test. This is perhaps the only important one. But lab test for hearing, there are a couple of them, like audiometry is very important, tympanometry, BERA, we'll talk about the full form a bit later, autoacoustic emission, short OAE, and electrocochleography. Okay, these are some of the important tests for hearing. And which are the main vestibular function tests which are of clinical in nature? A very important one is the caloric test, you can do fistula test, and things like Romberg's, Unterberger's, these kind of tests. And which are the main lab tests for checking the vestibule? We have electrocochleography. This one is pretty important. Electronystagmography. Optokinetic test. Galvanic test. Posturography. VEMP. Vestibular evoked myogenic potential. These are some of the important types of. I'll write the names, don't worry again. Okay, so we have clinical hearing test, we have lab based hearing test, we have clinical vestibular test, and we have lab based vestibular test. If I have to pick one name of the list, it has to be the tuning fork test. Tuning fork test is very important, very commonly asked in the exam, and it is slightly concept based. Okay, and so you have to know it properly. Now, before I talk about tuning fork test, you have to know the difference between air conduction and bone conduction. AC in short and BC is for air conduction, bone conduction, and you also have to know the difference between conductive hearing loss CHL versus sensory neural hearing loss. Now you have to know the concept of these two things, ACBC versus and CHL versus SNHL. Now let me draw this diagram that I keep drawing. Pinna, canal, tympanic membrane, middle ear with three ossicles. I draw three dots. Inner ear, cochlea. Eighth nerve carries the signal to the brain. The hearing part is the cortex where we finally hear the sound. We know this by now. So this is the entire hearing pathway. In this hearing pathway, we have pinna, canal, tympanic membrane, middle ear, ossicles, inner ear, nerve, brain, which is the most important thing for hearing. I can easily say that the most important thing for hearing is the sensory organ of hearing, organ of corti. Where is it located? In the cochlea. This is the cochlea. Let's assume that this red thing is the organ of corti. Just assuming. Sensory organ of hearing. What it means is that for hearing, you must be able to send the sound to this organ of corti. If you can send the sound to this organ of corti, rest will happen by default automatically, and the sound will reach the brain and the patient hear. We must be able to send the sound to this organ of corti. And sending the sound to the organ of corti, you have two pathways. One is air conduction pathway, AC. The other is a bony conduction pathway, BC. Now what is the basic difference? Now suppose this pen is the tuning fork. You strike it, it begins to vibrate. How do you check the air conduction? AC. You place the tuning fork outside the pinna here to check the air conduction, isn't it? And how do you check the bony conduction? The base of the tuning fork is placed on the mastoid bone, mastoid. So the sound travels through the mastoid bone and you can hear AC, BC. We know this. That means during air conduction, the tuning fork is outside the pinna. In this diagram, let's say this is your tuning fork outside the pinna and it is vibrating and producing sound. So how is this sound from this tuning fork going to reach the brain so that one can hear this sound? It's pretty logical. We have discussed this already. The sound of this tuning fork is first going to travel through the pinna, then through this canal, then through the tympanic membrane, and then middle ear and the ossicles, and finally goes to the organ of Cotta in the cochlea. And from here the sound travels through the eighth nerve to the brain, where you finally hear the sound. And we discussed this already. The important thing to realize here is that during air conduction, every part of the ear is used. Every part means pinna is used, canal is used, tympanic membrane, middle ear and ossicles, inner ear, nerve, brain, everything is used for air conduction, AC. And therefore, problem to any part of the ear is going to affect the air conduction. So no matter where the problem is, AC will always have a problem because AC is using everything. But during bone conduction, the tuning fork is placed on the mastoid bone here. And the sound from the mastoid goes directly inside the cochlea. So from the bone, the sound goes directly to the cochlea inside, and from there it travels to the nerve and the brain, and you hear a sound in the brain. This is bony conduction, where we use only this much. We do not use this much, right? Whereas in air conduction, we use everything. What it means is that if there is a disease in the external and the middle ear, if the disease is in this part of the ear, only AC should be affected, BC should not be affected, because BC is not using this part. Whereas when the disease affects this part of the ear, inner ear, nerve and brain, then both AC and BC should be affected because this part is used by both AC and BC, isn't it? That's the logic thing. So the blue marked area, only AC should be affected, and the green marked area, AC and BC both should get affected because both are using this part. Based on this, we have divided hearing loss into two types. If this part is involved, which is the external and the middle ear mainly, it is a conductive pathway. So it's called conductive hearing loss, in short CHL. Okay, so CHL stands for conductive hearing loss. And if this area is involved, affected, which is used by both AC and BC, then you have the sensory organ and the neural part. So it's called sensory neural hearing loss, SNHL in short, sensory neural hearing loss. This is how we divide the hearing loss into two main types, conductive hearing loss and sensory neural hearing loss, right? Now in sensory neural hearing loss, what is affected? In sensory neural hearing loss, we have the problems either in the sensory organ, which is cochlea, or the neural path, which is the eighth nerve. That's why sensory neural hearing loss is further divided into two types. Sensory hearing loss means either there is a cochlear disease, sensory organ, or the nerve is disease, neural path, sensory neural. So that's why it is divided into two types. When it is the cochlea which is damaged, it's called cochlear disease. Cochlea is damaged, cochlear disease. And if the nerve is damaged, which is after the cochlea, it is called retrocochlear disease. This term I told you before also is a very important term, right? So we have a cochlear disease and a retrocochlear disease. Both are subdivisions of sensory neural hearing loss. So hearing loss is divided first into conductive and sensory neural, and sensory neural is further divided into cochlear and retrocochlear diseases, right? So I told you already that we are going to discuss mainly the tuning fork test. Now tell me, which is the most commonly used frequency during a tuning fork test? We all know this is a very simple question, but it's kind of asked pretty commonly, and the answer is 512 Hz. The most commonly used frequency in a tuning fork is 512 Hz. We don't use lower frequency than this commonly, and we don't use higher frequency than this commonly. Why? If you use a lower frequency, which is 256, then it vibrates too much. So when you place it especially on the master to check the bony conduction, you can feel the vibration. Feel. See, normally you should not feel the vibration, you should hear the sound that is produced by the vibration. Difference. You must be able to hear the sound but should not feel the vibration. In lower frequencies, we can feel the vibration also. So sometimes there is no sound, you can't hear the sound, but you can feel the vibration and you confuse, you think it is a sound you hear. So it creates confusion because you can feel. So feel is the word. And if you use the higher frequency which is 1024, so when you strike it, it vibrates for a very short duration of time. You strike it, vibrates very short, it dies, it stops vibrating. So before you have put it here or here, it stops vibrating. So again and again you have to do repeatedly, So we use the word it dies very soon or it vibrates very short duration of time. So it is a cumbersome thing. Low frequency, you can feel the vibration. High frequency, it dies very soon, doesn't vibrate enough. So the 512 is the best option. Now what are the important types of tuning fork test? Tuning fork test can be of many types, but these are few important names that you have to remember. Everybody has heard the name of Renes, Weber's, ABC, which is very similar to Swabax. Binge is another important name, Gales. Okay. Then other like Binge, autotoxic drug test, Stenger's test, Simone Moyes test. So you can remember the names of many tuning fork tests, but essentially the first three. These are the three that they ask you in the exam most commonly: Renes, Weber's, and Swabax, which is sometimes called absolute bone conduction. They are not sometimes, they are different. There is a difference between Swabax and ABC, but they are very similar tests. So we include them in the same group. Now what is the difference between these three? How do you do Renes? How do you do Weber's? How do you do Swabax? In a Renes test, let's talk about Renes test. In a Renes, suppose this is the tuning fork, you strike it, it begins to vibrate. In a Renes, you check AC and then you check BC. AC, BC, and you ask the patient to compare the two. So what you say is, in Renes, AC is compared with BC. Comparison is done in 1 ear at a time. So once you have done Renes in this side, you may or may not do the Renes on the other side. Weber's. In Weber's, the tuning fork base is placed in the center on the board. This area usually, this is called the vertex. So we place on the vertex most commonly. You can place anywhere, but vertex is the most common area, so that it is in the center, so equal bony conduction will happen in both the ear. And you can compare the bony conduction of the right ear with the bony conduction in the left ear. So this is what is done in Weber's. Right ear BC is compared with left ear BC. There is no AC this time. What is done? BC of the two ears are compared amongst each other. This is Weber's. And what is done is Swabax, which is sometimes called ABC, very similar. In Swabax, the tuning fork, which is vibrating, is placed on the mastoid bone of the patient and then on your bone. Patient's mastoid, bony conduction, and your own bony conduction. So patient's bony conduction is compared with the examiner's bony conduction, assuming that the examiner's hearing is normal. So you're assuming that your is normal, and you're comparing patient's hearing with your hearing. This is Swabax. Okay. So Renes, AC is compared with BC. Weber's right ear BC is compared with the left ear BC, and ABC or Swabax, patient's bony conduction is compared with the examiner's bony conduction, assuming that the examiner's hearing is normal. Now, when you check AC, when you do Renes, AC is compared with BC, you do AC and BC, and you ask the patient which one is louder. Some may feel AC is better. We write like this: AC is better or more than BC. Some may feel BC is more, so we write like this: BC is more than AC. Obviously, if you are going to compare two things, one has to be, some will feel this is better, some will feel this is better. Either AC is better or BC is better. If AC is better, it's called positive Renes. If BC is better, it's called negative Renes. So Renes can be positive or negative, and each can further be divided into true positive Renes and false positive Renes. Similarly, Webers can be true negative can be true negative and false negative. Now we have four situations in tuning fork test: true positive, false positive, true negative, false negative. When you get true positive Renes, when the hearing is normal. So when the hearing of the patient is normal, if you do a Renes, you get a true positive Renes. False positive, if the patient has sensory neural hearing loss. SNHL stands for sensory neural. That means if you get positive Renes, AC is more than BC, you are not sure. It could be normal or it could be SNHL. If it is normal, it is true. If it is SNHL, it is false. Okay. And similarly, when you get true negative Renes, CHL, conductive hearing loss, and false negative, dead ear. When the ear is completely gone, hearing is zero. Dead ear is usually when we have a severe SNHL. Okay. Once again, if you have negative Renes, which is BC more than AC, you are not sure is it CHL or is it dead ear, which is completely gone, severe SNHL. Okay. So true positive is normal, false positive is SNHL, true negative is CHL, and false negative is severe SNHL. Now what it tells us is that if you do a Renes and if you get a true positive Renes, you know it is positive, but you don't know whether it is true or false. You're not sure it is SNHL or normal. Similarly, if you get a negative Renes, you don't know it is true or false, so you don't know it is CHL or severe SNHL. That means by doing a Renes, it does not give you a complete picture, complete information. And that's why we may have to do Webers, where we have to place it here, bony conduction, so that the patient can compare the two sides, and we ask the patient which side is better or louder. Some patient feels this is better, I can hear this one better. Some feels I hear better in this side, and the others who might feel it is equal on both the sides, equal. When it is equal on both the sides, we call it centralized Webers. So I'm writing here, centralized Webers. So when I say centralized Webers, means the patient is hearing equally on both the sides. But if the patient hears one side more than the other, we call it lateralized Webers. Okay, so Webers is either centralized or lateralized. How do you show in a chart? In a chart, we draw like this. Suppose this is the right side and this is the left side. Okay. And between the two, we draw a line like this. Let me remove this. Between the two, we have to draw a line like this. And you draw the arrow on the side the patient hears. Like this. And if the patient says that I hear equal on both the sides, you have to draw arrow on both the sides. If you have drawn like this, arrow on both the sides, right and left, you know that it is centralized Webers. You don't have to write centralized now. If the patient says I hear on the left ear only, not in the right side, then you draw the arrow like this on the left side. This is lateralized to the left side. And if the patient says I hear on the right side, you draw arrow on the right side. This is lateralized to the right side. Now the first arrow is centralized, second is lateralized to the left side, and third one is lateralized to the right side. So Webers is either centralized or lateralized. Now when is it centralized? Now this is not 100% true, but for practical purposes, centralized Webers is seen when both sides are normal. That means right is normal and left is also normal. Both sides are normal, then and only then you get centralized Webers. So if you do a Webers and the patient says I hear equally in both the sides, you can say with all confidence that both your hearing ears have equal normal hearing, and that's why you're getting a centralized web burst. But when do we get a lateralized web burst? Lateralized web burst is seen in conductive hearing loss as well as in sensory neural hearing loss. Conductive as well as sensory hearing loss, both will give us a lateralized web burst. Now this is very important. In SNHL, web burst is lateralized to the opposite side. So if you have SNHL on this side, web burst will go to this side. If you have SNHL on this side, web burst will go to this side. So in SNHL, web burst gets lateralized to the opposite side, and in CHL, web burst gets lateralized to the same side. This is very important. In SNHL, web burst goes to the opposite side. In CHL, web burst goes to the same side. Right? Very, very important. Now, what does it mean? That in this case, if it is SNHL in the first one, which side? SNHL. It is this side. SNHL. Yes or no? That's why web burst is going to the other side. In SNHL, web burst goes to the opposite side. In the next one, last one, if it is SNHL, which side? It is this side. Again, we understand. In SNHL, as we see in both days, web burst goes to the opposite side. If it is CHL in the first one, which side? Same side. In CHL, web burst goes to the same side as the arrow. So CHL has to be this side. This is the CHL, same side as arrow. In the next one, if it is CHL, which side? It is this side. So notice, in CHL, the arrow is on the same side. In SNHL, the opposite is on the arrow is on the opposite side. So CHL same side, SNHL opposite side, and centralized if it is normal on both sides. Now, what does it mean? If I tell you that I know a patient where I do web burst, this is the right side and this is the left side. Okay, I know a patient where I've done a web burst and this is the result. It is going to the left side. Now, what is your answer? What is the problem in this patient? Let me create some space here. I'll come to this question once again. Now, what I'm going to tell you now is actually the most important thing to understand in a tuning fork test. If you understand the meaning of this, what I'm going to tell you now, then tuning fork becomes very easy to understand and crack. And it's very simple actually. Now, this is the right ear, this is the left ear. I do a web burst, I get this side, web burst going to the left side. Now, what is the problem in this patient? It means maybe this side is normal, maybe. If this is normal, this has to be CHL. Now, somebody who has the combination of right normal and left CHL, if you do web burst will go to the left side, because left in CHL web burst goes to the same side. In this case, left side. If this one is normal, then this has to be SNHL, because SNHL web burst goes to the opposite side. Now, whether it is this combination, the first one, or this combination, the second one, in both the cases, the web burst will go to the left side, right? Or both. This is SNHL plus this side is CHL. If you do web burst in this, again it will go to the left side. Or if this one is more SNHL and this one is less SNHL, again web burst will go to the left side, because in SNHL it goes to the better side. And if this is less CHL and this one is more CHL, web burst will go to the left side. So whether it is this situation, combination, or this combination, or this combination, or this combination, or this combination, any of the 5 combinations, web burst will only go to the left side. And pretty logical. So this is what it means by lateralized web burst. When I say lateralized web burst, what is the meaning of that? It means the patient is having one of the 5 things, combinations. Which one? You don't know. You can't predict. It is one of the 5, but you are not sure which one. Remember in Renes, if you get positive Renes, it is either normal or SNHL, we're not sure. Similarly, Weber's also does not give you a confirmation. If it is centralized Weber's, then by and large you know that both are normal. But if it is lateralized Weber's, then it is one of the five. Which one you are not sure. It means alone Rene's does not give you all the information. Alone Weber's, it does not give you all the information. And that's why every time you do a tuning fork test, you have to do both Rene's as well as Weber's. And when you do Rene's and Weber's have a result of both, like a basic mathematics, you can deduce the correct answer. Right? So Rene's and Weber's are always done together. But sometimes, having done both of them, you still cannot be sure. There is a doubt left. In those cases, we do Swaback's test. So Swaback's is not done commonly. It is done only when Rene's and Weber's fail to give you a confirmation. So once again, if it is centralized Weber's, both sides are by and large normal. If it is lateralized Weber's, either it is CHL on the same side or SNHL on the opposite side, right? In SNHL, Weber's goes to the opposite side. In CHL, Weber's goes to the same side, right? And like I told you, that sometimes having done Rene's and Weber's, you still have a doubt. In those cases, you have to do Swaback's, where the patient's bony conduction is compared with the examiner's bony conduction, assuming that the examiner is normal. So when you compare patient and examiner, the patient might feel that his hearing is same as you, equal hearing. So we write equal hearing in patient and examiner, which is shown with an arrow like this. Small arrow, equal hearing. Or patient might feel that his hearing is less than you, which is shown like this, less than you. Or patient might say that his hearing is more than you, which is like this, right? So patient's hearing is either less than you or more than you or equal to you, one of the three things. When is patient's hearing equal to you? You are normal, assumed, and patient has equal to you, patient must be normal. So if patient's hearing is equal to you, then patient's hearing is normal. That's why it is equal to you. When is patient's hearing less than you? When the patient has SNHL, sensory neural hearing loss. And when is patient's hearing better than you, more than you? When the patient has CHL. If you remember, we are comparing bony conduction. In CHL, bony conduction goes to the same side. So patient has more CHL, that's why patient hears bony conduction better than the examiner. So equal to you, patient is normal, less than you, patient has SNHL, more than you, patient has CHL. Now there are two very important things here. In Rene's, there are two options, either positive Rene's or negative Rene's. In Weber's, there are two options, either centralized Weber's or lateralized Weber's. But here we have three options, either equal or less than you or more than you, right? Now second thing, in Rene's you are not sure. If it is positive Rene's, either normal or SNHL. If it is negative Rene's, either CHL or dead ear. Weber's also you are not sure. If it is centralized Weber's, you are sure both are normal. But if lateralized Weber's, is it same side CHL or opposite SNHL or both? The five options like this one. But in Swaback's, there is only one option for each of them. Equal means the only option is normal, no other options. If the patient hearing is less than you, the only possibility is patient has SNHL. And the patient's hearing is more than you, then the only option is patient has CHL. There is no either this or that. Meaning, the Swaback's will always give you a confirmation, isn't it? That means if I ask you to do one tuning fork test and give me a confirmation, which one do you do? Swaback's test. It will always give you a confirmation. There is no dilemma here. Now my question is different. If Swaback's is such a good test, which always gives you a confirmation, then where is the need for Rene's and Weber's? Why do we do a Rene's and Weber's? We should abolish all other tests, only concentrate on Swaback's that always give you a confirmation. In fact, we don't do the Swaback's in the as a first test. We only do Swaback's when the Rene's and Weber's leave some doubt. After doing Rene's and Weber's, we are not sure, only then we do Swaback's. Why this? a very important thing, that SWABX, we have assumed something. We have assumed that the examiner is, मान के चलते कि the examiner normal है. And maybe that is not true. The assumption is not true. You know? So because we assume something in this, it loses its scientific credibility. It's not a credible test. It's the best test. It's not a credible test. Credibility नहीं है क्योंकि मान के चलते हैं. You know? That's why it is not the first line of investigation. It is a third, maybe Rennie's, Weber's, and if it is required, then you do SWABX. Right? So we'll talk about these, and then about masking. When you're tuning for test, you may have to do masking also. Now during AC testing, the masking is required when the threshold of the sound hearing is more than 40 decibel. What is threshold we'll know when we talk about audiometry. But remember that if the threshold of hearing of the patient is more than 40 decibel, then you have to do what is called the masking. In AC, this is for AC. And when is masking done for BC? During BC testing, masking is required when the threshold is more than 5 decibel. Right? That means in a bony conduction, masking should always be done. 5 decibel hearing loss to hoga hi. It will be always be there. So masking is practically always required for bony conduction. Now this tells us something very important. That bony conduction can detect hearing loss as little as 5 decibel. You know, even if the hearing loss is 5 decibel only, bony conduction can detect that. But AC, air conduction, cannot detect hearing loss which is less than 15 decibel. So if you want to do a tuning for test or AC basically, then the hearing loss must be more than 15 to 20 decibel. But if you want to do BC, 5 decibel will be detected. So which is the more sensitive tuning for test? BC is the most sensitive tuning for test, and Weber's we do only BC. Remember, right here BC is compared with left here BC. So if I ask you Rennie's and Weber's which is more sensitive, Weber's is more sensitive because it is checking the BC, and BC can detect as little as 5 decibel hearing loss. Right? Few points about other tests like binge. Binge and Galley's. For Galley's test, you have to use an instrument called Siegel's speculum. If you want to do a Galley's test, you have to use a Siegel's speculum. And the result of binge is similar to the result of AC, that means of Rennie's. If binge is positive, it is normal or SNHL. If binge is negative, it is CHL, similar to Rennie's. Now there is one very important point, that binge, if it is negative, if binge is negative, it is taken diagnostic of autosclerosis. Although always it is not true, but this is what you have to know. You have to know this, that negative binge is autosclerosis. So let's talk about 1 or 2 points more about this tuning for. You have to remember all these names that I've given. Just remember that Galley's test, you have to use what is called Siegel's speculum. We'll talk about this speculum later on. I'll show you the diagram, also a picture actually. But for Galley's test, you have to use Siegel's, and the result of Galley's is interpreted similar to Rennie's. Remember, Rennie's positive is normal or SNHL, and negative is CHL. Galley's is also interpreted similarly. But there is one very important point, that negative Galley's is taken as diagnostic of a disease called autosclerosis. This is a very important point. Although this is not always true, but this is true for you, that negative Galley's is diagnostic of autosclerosis. Very important MCQ, very commonly asked. Now let me tell you something important here. See, so far we have talked about tuning fork test. What is tuning fork test? What is the information tuning fork has given us? Tuning fork test tells you whether there is a hearing loss or not. And if there is a hearing loss, is it CHL or SNHL? Is it right side or left side? So this is only talking about hearing loss. It does not tell you the cause of the hearing loss. It does not name the disease that is causing the hearing loss. We know this so far. But otosclerosis is the name of a disease. So negative Galley's is the only tuning fork finding that gives you a diagnosis, a name of a disease, otosclerosis. No other tuning fork finding of no other tuning fork test gives you a diagnosis, a name of a disease, except negative Galley's. That's why it's a important tuning fork test, right? So these are the main points about tuning fork, which is very, very important. Let's take one or two questions. Now this is question number 1, where right ear has AC more than BC, left ear also has AC more than BC. On the right ear, ABC is reduced, as you can see. Left ear also ABC is reduced, and Weber's is going to the left side. Now this question has finding of Renes, Weber's, Swaback's, all the three. And based on these three, what is the diagnosis or what is the problem? Which ear has what problem? See, if it is AC more than BC, or if it is reduced ABC, reduced ABC means what? The only option if it is reduced ABC is SNHL. So this side ABC is reduced, this side has to be SNHL. Because and in SNHL you can get AC more than BC, false positive. This side is the same thing. The ABC is reduced, so this also has to be SNHL. And again you can get AC more than BC because false positive. So one thing is sure, that bilateral SNHL. And if it is bilateral SNHL, Weber's goes to which side? To the better side. So this is better ear, this is worse ear. So this is worse side, more hearing loss. This is better side, less hearing loss. So what does it tell us? It tells us that both side is SNHL, right side has more SNHL. It is worse compared to the left side. This is your answer. Bilateral SNHL, right side is more SNHL than the left side. Right? Very important. Now, second thing, if I ask you in this patient, what is the problem? You say bilateral SNHL, right side is more than the left side. If I do not give you ABC finding, suppose this is not given, okay, only rest of the thing is given. Same question, I have removed ABC. So now the question says that right side AC is more than BC, left side is also AC more than BC, Weber's is going to the left side. What is the problem now? What is the diagnosis now? If it is AC more than BC, both sides, there can be no conductive hearing loss. So conductive hearing loss is ruled out because AC more than BC cannot happen in CHL. In CHL, BC is more than AC in both the sides. And if it is lateralized Weber's, both cannot be normal. If both are normal, it is centralized. If it is lateralized, it has to be either CHL or SNHL. So there is a problem. It is not normal. And what is the problem? The problem cannot be CHL, so there is SNHL. Which side is SNHL? In SNHL, Weber's goes to the better side. So this side is SNHL. Confirmed. So this is confirmed. Right side is SNHL. This is your diagnosis, or this is your answer. The right side is SNHL. Okay, right side is SNHL. What about left side? If I ask you, you say that right side with this finding, right side is SNHL. What about left side? Now left can be SNHL, but less than the right side, less than this, or it can be normal also. So right side in this case can be one of the two. Now how do you know, is it this one or this one on the left side? Because right is confirmed, it is SNHL. And to find out this, you have to do Swaback's test. So this was a question asked in AIMS once, that they give you this kind of finding and they ask you what is the next best thing to do in this patient. The next best thing to do is Swaback's on the left side, because left side I'm not sure it is SNHL or CHL, and this dilemma will be cleared by Swaback's test. So remember, now you notice how where Swaback's is important, where it can be used. Okay, let us take a next example, second example. In this, The same example that we discussed, not the same, it is different actually. Right is AC more than BC, left is BC more than AC, and Weber's is going to the right side. ABC is not given, swab X is not given. Okay, if BC is more than AC, it is either CHL or dead ear, which is severe SNHL. Yes or no? So it is one of the two. If it is CHL, in CHL Weber's goes to which side? In CHL, Weber's goes to the same side. It should be like this. Is Weber's going to the same side? No, it is not. It is going to the opposite side. So CHL is ruled out because Weber's is going to the other side. So the only option left is dead ear or severe SNHL. Because it's SNHL severe, Weber's goes to the opposite. So left is severe SNH. Okay? Or you can say false negative release. If you remember, in dead ear or severe SNHL, this negative is false negative. So this is what you can say, left side is false negative release or left is dead ear, severe SNHL, whatever is the question. What about right side? See, if right is normal, AC more than BC, it is either normal or SNHL less than this side. This is severe, so this has to be SNHL less than that. How do you break this dilemma? Is it normal or SNHL? Again, swab X. So to know this, you again have to do swab X test. Right? Again, they may ask you what is the next best thing to do in this patient. You have to do swab X test on the right side this time. Right? These are the types of questions they may ask you in tuning fork. You have to practice a little bit and you get the hang of it. So this will complete all the important points about tuning fork test, which is very, very important. And then we talk about pure tone audiometry. In short, PTE. Like we discussed, audiometry is a lab-based hearing test. It is done in a soundproof room. And when we do audiometry, we plot a graph. That graph that we get is called audiogram. And an audiogram has two axes. There is a y-axis and an x-axis. X and y. Right? And we plot a graph between the two. The graph that we get is called the audiogram. What do we take on the x-axis? On the x, we take the frequency of sound that we check. Frequencies. And on the y-axis, we take the loudness of the sound, which is also called SPL or intensity. Same thing, loudness, SPL, intensity. SPL stands for sound pressure level. Sound pressure level. Basically, audiogram is a graph between loudness and frequency. That's what you can say. Okay. Now, what are the frequencies we check during audiometry? We start usually with 250 Hertz sound. Next is 500 Hertz, then 1000 Hertz, 2000 Hertz, 3000, 4000, and 8000. These are the frequencies that we usually check during audiometry. It is not hard and fast rule that you have to check only these ones. You can check in between also some other frequencies. But minimum, which is 250, and maximum 8000, this is fixed. We usually don't check less than 250 Hertz and we don't go beyond 8000 Hertz. So these are the two values you have to remember: minimum frequency during audiometry and maximum frequency during audiometry. 250, 8000. If you check a frequency which is beyond 8000, 9000, 10,000, 12,000, whatever, then it becomes high frequency audiometry. We call it a high frequency audiometry. That means if I tell you that I've done a high frequency audiometry, high frequency, then it clearly means that your check frequency more than 8000 decibel also. High frequency. And the question they ask you is, when do you do a high frequency audiometry? When do you check frequencies more than 8,000 during audiometry? And the answer is, if you suspect ototoxicity. So if you suspect an ototoxicity in a patient, then you may have to do a high frequency audiometry, especially gentamicin, aminoglycosides, any of them. And a very good clinical scenario is MDR tuberculosis, multi-drug resistant tuberculosis. 4 drug, you add a 5th one, say streptomycin. So once you have added streptomycin, few weeks down the line, you want to know whether the patient is having a problem or not, because it can lead to ototoxicity. And then you can do this high frequency audiometry. It tells you whether the patient has a problem or not. Otherwise, we don't do this. What is the unit of loudness? The unit of loudness is decibel. So we start with, let's say, 0 decibel, next 5 decibel, 10 decibel, 15, 20, 25, 30, 35. Like this, you can go up to 90 decibel. We go in a reverse. Up is less value. If you go down, the value keeps on increasing. Right? Now you have to know 2 things here. When you increase the loudness during audiometry, it is always increased in the multiples of 5. 0, then 5, then 10, then 15, multiples of 5. And although we check till 90 decibel, which is usually done in most of the patients, but the maximum allowed limit is 120 decibel. During audiometry, you can go up to 120 decibel if required, but usually 90 suffices. So once again, it is a graph of loudness versus frequency. So what you do in audiometry is that the patient is placed in a soundproof room. It's like a lab. We fit the instrument onto the patient. Instrument is fitted like this. We explain the procedure to the patient. Patient sits with both the hands on the table, and only 2 instructions. 1, if you hear a sound, you keep sitting like this. If you hear a sound, raise your hand. So when you raise your hand, I know that you have heard the sound. And the second instruction is, if you hear the sound in the right ear, raise your right hand. If you hear in the left ear, raise your left hand. So depending on which hand you have raised, I know whether you have heard in the right ear or the left ear. That's it. Right? And then what we do, we select the minimum frequency. What is the minimum frequency I will select? The minimum frequency I will select is 250 Hz. And then I give a sound of 0 decibel. Right? I select a 250 sound frequency and give a sound of 0 decibel, and I ask the patient whether you've heard or not. Or I just look at the patient has raised the hand or not. If the patient does not hear the sound, will not raise the hand, so you know the patient has not heard the sound. That means you have to make the sound louder. So you make it 5 decibel. Make it loud. Again the patient has not heard. Then you make it 10 decibel. Not heard. 15, not 20. Like this you come on increasing the loudness till the patient hears the sound. Right? So between 0 and 90 or 0 and 120, most people hear the sound between this. So you want to know what is the minimum frequency the patient hears the sound. Right? And this you do for all the frequency. First with 250, then 500, 1000, you do for all the frequency, you repeat the same thing again and again. That's audiometry. Okay. So imagine that this patient came to you, you are doing audiometry, you explain the procedure, put the instrument, give the instruction, and you select 250 Hz, give a 0 decibel sound, patient did not raise the hand, 5 decibel the patient did not raise the hand, 10 decibel the patient did not raise the hand, 15 decibel the patient raised the hand, whichever, right or left, doesn't matter. Okay. So at 15 decibel, at 250 Hz, at 15 decibel, you put a cross like this. So when you see a cross like this, you know that the minimum sound at 250 Hz is 15 decibel. Less than 15, the patient cannot hear the sound. The 15 decibel becomes the threshold of hearing. This is a very important word, threshold. Okay. What is threshold of hearing? Threshold of hearing is the minimum sound that you hear in a particular frequency. That means if your threshold is 15 decibel, suppose like in this case, then the minimum sound at 250 you hear is 15 decibel. Less than 15 you cannot hear. 10 decibel, 5 decibel, 0 decibel you cannot hear, because this is your threshold. So threshold is a minimum sound that you hear in a particular frequency. And this is what audiometry does. It finds the threshold of all the frequencies. So right now in this case we have already found the threshold of 250, which is 15 decibel. Now I want to find out the threshold of next, which is 500. So I'll select 500 now. In the same patient, again start with 0. So suppose 0 the patient did not raise the hand, 5 the patient did not raise the hand, 10 no hand, 15 no hand, 20 she raised the hand. So this time I'll put a cross at 20 decibel. See, same patient, different frequency can have different threshold. At 250 the threshold was 15 decibel, at 500 the threshold was 20 decibel, same patient. And it's quite possible to have different threshold in different frequencies. That's why we're checking all the frequencies. Now I go to the next one, 1000. Suppose this time the threshold was 0 decibel, so I put a cross here. Suppose 2000, again the threshold was 0 decibel. 3000 threshold came out to be 10 decibel, so I put a cross here. 4000 the threshold came out to be 5 decibel. And 8000 suppose it came out to be 20 decibel. Suppose this is the answer. It can be anything. Any patient can have anything. This is just an arbitrary figure I have taken. So I found threshold of all the frequency that required. My audiometry is done. But once I get all these thresholds, all this cross, I have to join them. Starting with the first one, go to the next one, the next one, next one, next one, next one, and next one. I join all of them. And I get a graph. This graph is the audiogram. This graph is the audiogram. So audiogram is a graph that shows threshold of different frequencies. In other words, if I ask you what does the audiometry do, you see audiometry essentially finds the threshold of the frequency that you desire. So everybody's graph is going to be a little bit of different from each other. The shape may vary, the level may vary, depends on your threshold. But whatever, once you get the threshold at 25, this is 25, yes or no? At 25, we imagine there is a line like this. I'll draw a line. We imagine there is a line at 25 decibel like this. Why? This is very important. Why? Because according to WHO, I'm going to create some space here. According to WHO, the minimum threshold or the normal threshold is between 0 to 25 decibel. This value is normal. So if somebody's threshold is between 0 and 25, that person's hearing is considered as normal. So when I say 0 to 25, I can say less than 25. If somebody's threshold is less than 25 decibel, the hearing of that person is considered as normal. And if somebody's threshold is more than 25, 26, 27 and beyond that, that means the person has a hearing loss. In other words, if the graph is above this 25 mark, it is normal. And if the graph is below like this is hearing loss. This shows hearing loss. So this is the main advantage of audiometry. Whether the patient has a hearing loss or not, this you can know by doing the audiometry. How do you know? If the graph is above this 25 mark, it is normal. If the graph is below this 25 mark, it is hearing loss. So the moment you look at the audiometry, first look you can tell the patient whether your hearing is normal or not. And as the hearing loss increases, the graph keeps going down here. Let's say there are 3 graphs of hearing loss. Let's call this is A, B, and C. All 3 are below 25. So all 3 have hearing loss. Yes or no? So what is the difference between the 3? Severity. This is less hearing loss. This is more hearing loss. This is more than that. So as the graph keeps going down, the hearing loss keeps on increasing. Right? Then if somebody has an audiogram which is partly below, partly above, let me use a different color so that you don't get confused. If the audiogram is like this, like this, like this, like this, like this. Suppose partly below, partly 20 above. Now what do you see? Is it hearing loss or normal? Because some frequencies are normal range, some are in the hearing loss range. In that case, what do? You get the ratio of these three frequencies, these four frequencies actually. You take the threshold of this 500, 1000, 2000, 3000, this four frequency, and take an average. You take all the four values, add up them, and divide by 4. So you get an average. If the average value is less than 25, 25 and less, it is normal. If the average value is more than 25, 26 and more, then it is hearing loss. So you take the average of these four frequency in case the graph is partly below and partly above. Okay. Now, each patient, we do audiometry how many times? We do audiometry 4 times. Why 4 times? Once you do right ear AC, then you do right ear BC, then left ear AC, left ear BC. Okay? Right ear AC, right ear BC, left ear AC, right ear BC. So you might have 4 graphs sometimes. So if you have 4 graphs, let's say something like this, one graph is like this, one goes like this, one is like this. Suppose. So how do you know which is right ear, which is left ear, which is AC, which is BC? Get confused. So what we have done, so that we don't have this kind of problem, we have used different color ink. So if you use red ink into the audiogram, it is for right ear. And if you use blue ink, like in this case I've used blue, it means left ear. So color will tell you. If it's red color, so if I have to draw audiometry of the right ear, I will use this color to draw. So this is clearly right ear, and this one is clearly the left ear. So color will tell you, so no problem. So side gets controlled. You know which side, right side or left side, looking at the color, but you don't know which is AC, which is BC. So with blue you will have 2, one AC, one BC. Red also you will have 2, one AC, one BC. So how do you know which is right ear, which is left ear, which is AC, which is AC, which is BC? For that we have devised a method using symbols. Like in this case, I've used a symbol. What is the symbol I've used here? The symbol that I've used here is a cross. Can you notice I've used cross or X, you can call it. So they're symbols, and each symbol on audiometry stands for something. Let's know what are the symbols that we use. I'm not going to give you all the symbols. I'm going to give you the important ones that you must remember. Right ear, left ear, AC, BC. So how do you show right ear AC? Right ear AC is shown with a circle like this. That means if you do audiogram with the right ear AC, you'll do like this, like this. Circle. How do you show AC of left ear? AC of left ear is shown with a cross or an X. So in this one, I've used a cross, meaning this is left ear AC. So if I show you this audiogram only this much, and I tell you, please comment on this, you say, I don't know too much because I can only see one graph. Ideally there should be 4. But with this one, I can tell you that right ear AC, left ear AC is normal. Isn't it? Left ear blue, cross is AC, is above 25 normal. So left ear AC is normal, rest I cannot comment. Okay, how do you show right ear BC? Right ear BC is shown with this, or you can use this alternatively, any of the two. And left ear BC is opposite of this one or this one, any of the two. Okay, so as you see that this one is right ear AC, this is left ear AC, any of the two is right ear BC, and this is left ear BC. Now let me remove this. What information that audiometry give you? What are the main things that we know through audiometry? The main thing that we know through audiometry are A, whether hearing loss is present or not. If it is below 25, it is above 25, based on that. Then you have to know type of hearing loss. Means is it CHL or SNHL? Third, side of hearing loss, right side or left side or both, light and left, both sides. And fourth is the degree or severity of hearing loss. Audiometry gives us these four main information, and fifth, it can be kept as a record. It's a record. So you show the audiogram to prove that you have a hearing loss. So these are some of the important uses of audiometry. We know how to know whether it is hearing loss or not, right? Below 25 is hearing loss, above 25 is normal. Side, blue is left side and red is right side, and symbols can be used. Degree, the more it goes down, the more is the severity of hearing loss. It's a record, but how do you know the type? This is important. How do you know is it CHL or SNHL? This one is very, very important. So let's talk about this. This is actually the most important thing for you. Now for hearing loss, the audiometry has to be below 25, yes or no? Now, if only AC is below 25, only if AC audiogram is below 25 mark and BC is above, this is conductive hearing loss. That means if somebody is a conductive hearing loss, only AC will go below 25 in that side, BC will remain above 25. If both AC and BC are below 25 mark, then if both AC and BC are below 25, it is either SNHL or mixed hearing loss. So if it is purely SNHL, both go below 25. If it is mixed hearing loss, again both go below 25. So if both are below 25, we are not sure is it SNHL or mixed. Now comes the role of the gap between the two, AB gap. So if both are below 25, and how much is the gap, that is going to tell you is it SNHL or mixed. If the AB gap is less than 15 decibel, if both are below 25 and AB gap is less than 15 decibel, it is sensory neural hearing loss. And if the AB gap is more than 25 decibel, more than 15 decibel, then it is mixed hearing loss. Right? So what it means is that when you get an audiogram like this, the first thing you have to look is what is below 25. You don't have to bother what is above 25. Above 25, everything is normal. What is below 25? If there's nothing below 25 line, everything is normal. But if there is something below 25, any graph, then there is a problem. If the red is below 25, the problem is the right ear. If the blue is below 25, the problem is the left ear. If one red, one blue, or if both red and blue are below 25, both will have a problem. If only one graph is below 25, only one, like this, let's say one is above, one is below, it is purely CHL. You don't have to think CHL. One below, one above means CHL. In CHL, this has to be AC, this has to be BC. It is, the symbols are not matching, but still, just to explain. So if I remove this, if I only show you this much, then you can say there is a problem. If I say tell you this is AC, then you can say the problem is conductive hearing loss, because conductive hearing loss, AC goes below 25, But if I show you a graph which is like this, then this is BC, this is AC. If both are below 25, that means it is not CHL. It is either mixed or SNHL. If the gap is very, AB gap is very little, they're less than 15, they're very close to each other like this one, this is perhaps a sensory neural hearing loss because the gap is not much. But if I remove this and draw an audiogram here, then the gap is too much. This is BC. Okay, so if the gap is more than 15 decibel, like in this case is shown, it is mixed hearing loss, right? And you have to see it in right ear or left ear. So this is what you do when you get an audiogram. First see what is below 25. If only one line is below 25, it is CHL. If there are two lines below 25 graphs, it is not CHL. It is mixed or SNHL. If the gap is less, SNHL. If the gap is more, CHL. So let's take an example. So look at this audiometry. This is just to show that everything is below 25. The 25 mark in this diagram or in this audiometer is somewhere here. Yes or no? 25 is somewhere here. It is below, and both red and blue, both are below 25. So both the ears have hearing loss. Just to show, we'll come to this a little later. Now tell me, this audiogram tells you what? It is only showing the left side, it is not showing the right side, isn't it? And AC is below and BC is above. So it's a purely conductive hearing loss on the left side. This is purely conductive hearing loss on the left side. Now that you know how to crack an audiogram, how to know it is conductive hearing loss or sensitive neural or a mixed hearing loss, let us know a few special types of audiograms. For instance, sometimes in the audiogram it goes like this, there is a sudden dip like this at 2000 Hz frequency. So when you have a dip like this at a 2000 Hz frequency, this dip is called Carhar's notch. And this is seen in autosclerosis. Autosclerosis will show you a Carhar's notch, a dip at 2000 Hz like I've shown here. If you see a similar dip at 4000 Hz, for instance your graph is going like this and the dip is at 4000 like this dip is called acoustic dip. Acoustic dip. And acoustic dip is a feature of noise induced hearing loss. NIHL stands for noise induced hearing loss. That means noise induced hearing loss shows you an acoustic dip, which is a dip at 4000 Hz frequency. Then I'll use a different color. Sometimes you have an audiogram which is like this, something like this. As the frequency increases, the graph goes upwards. This is called upward sloping audiograph. Upward sloping. Sometimes we call right sloping audiogram. What this audiogram tells us that there is more problem at the low frequency because it is at a lower frequency, it is lower down. As you increase the frequency, it goes up. There is a less problem at the high frequency, upward sloping. And this is a feature of Meniere's disease, early stage of Meniere's disease. In early stage of Meniere's disease, upward sloping audiogram can be seen. And the last one, I'm using a different color. This color is never used actually, but just to show you. If we get an audiogram which is like this, U-shaped, in the mid frequency maximum problem, less and high frequency the problem becomes less. U-shaped is congenital deafness. So U-shaped, which is also called trough shape. U-shape or trough shape audiogram is congenital deafness. So these are some of the special audiograms where there is a sudden dip at a certain frequency. Right. Now, if you remember, I told you that threshold, what is the normal threshold? Less than 25, 0 to 25. What is hearing loss? More than 25. But when do you call it mild hearing loss, moderate, severe, or profound? Oh, for that we have the chart or a table that I'm going to show you. But before that, let's take some examples. Let's exercise our brain. Now, I'm going to show you some audiograms. You try and make diagnosis, and then I'll tell you the answers. If I show you an audiogram like this and ask you what is the problem, what do you see? Right ear both are above 25, so right is normal. Left ear both are below 25, so left side is a problem. And what is the problem? It is either SNHL or mixed, but because they are very close to each other, it is SNHL on the left side. So this is SNHL on the left side. Okay, if I get a graph like this, now what? Both the ears, one is above, BC is above, AC is below, so it's bilateral conductive hearing loss. Conductive hearing loss on both the sides. Third, if I show an audiogram which is like this, then on the right ear, one is above, one is below. So right is conductive hearing loss. And left, both are below 25 and the gap is too much. So left is a mixed hearing loss. Right is conductive hearing loss, left is a mixed hearing loss. If I show you a graph which is like this, then of course it is Kaharsh-Notch, deep at 2000, autosclerosis, right? So these are some of the types of audiogram that you might get. You need a little bit of practice, and I think this much is sufficient for you to know. Now this audiogram shows both are below 25, red and blue, so both have hearing loss. They are only showing AC, they are not showing BC. So that's the thing. It's not a complete audiogram. Now look at this. See, if your threshold is less than 25, then there is no impairment. Hearing is normal. If your threshold is between 26 to 40 decibel, then there is a mild hearing loss. It's called mild hearing loss, slight impairment, mild hearing loss. If your audiometry is between 41 to 60, it is moderate hearing loss. This is mild, this is moderate. If the threshold is between 61 to 80, it is severe hearing loss, severe impairment. If it is more than 81, it is profound hearing loss. So they ask me in the exam, and this is the WHO criteria, that what is the criteria for mild hearing loss? If the threshold is between 41 to 26 to 40. What is moderate hearing loss? If the threshold is between 41 to 60. What is severe hearing loss? If the threshold is between 61 to 80. And what is profound hearing loss? When the threshold is more than 81 decibel, it becomes profound hearing loss. Just remember this, not too much. So tell me this question. In this, you can only see the left side, you can't see the right side. One is above, one is below. Clearly, it is left-sided conductive hearing loss, isn't it? Left is conductive hearing loss. Next one. What do you see here? If you notice, there is a sudden dip at 2000 hertz frequency roughly. It's not, yeah, it's written here. 2000 hertz frequency, there is a sudden dip, this one. This is the Cahardt's notch dip. That means this patient is suffering from autosclerosis. Next one. Can you see this dip again? This dip is at 4000 hertz. So this is noise induced hearing loss, 4000 hertz. This is an upward sloping, right sloping, early stage of Meniere's disease, right? So these are the types of audiometries that you might come across and you should be able to diagnose. So audiometry, you really have to be able to diagnose based on audiogram. They ask you to crack an audiogram, and tuning fork, again, it's important. So these are the two important investigations that we have done. The rest that we are going to discuss now are less important from the exam point of view, but we are going to discuss all of them, all the important. Okay.